Hello and welcome to the SMARTElectrode webcast. So the topic for today is, do you use EDM machines in your company and wonder how to directly integrate information from your design? At first, I would like to introduce us. My name is Florian Hamrich. I am the product manager for SMARTElectrode, and I'm the presenter for today, and my colleague Florin Tudose is the organizer, and he's going to handle the questions you may have and write them to the chat. Some hints before I am going to start. At first, I hope everybody can hear me well. If not, please write a message into the chat window. This webcast will be recorded and you will get an email notification when it's available for later download. After the webcast, we are going to have a short questions and answer sessions. And please use the chat function to ask Florin your questions, and he's going to pass the questions to me. So what are we talking about? At first, I would like to present one of the bigger changes in SMARTElectrode 12. And after that, I would like to talk about the functionality and features in SMARTElectrode to streamline the process and to forward information to the next process steps. So these are the measuring points and color codes for CMM, or computer added quality, and the new implemented manufacturing templates for Creo NC. These are coming with version 12.01, and the new implementation of the interfaces to EDM. And after that, the questions and answers, if there are any. So, okay, let's start with the new feature in SMARTElectrode 12. There has been a major change to the cutout functionality. The offset and the solid for the cutout is not calculated fully automatically by the software. It comes now with a user interface, which gives you the chance to adjust size and position. And in addition, you can start the user interface again for redefinition. And some additional information about this cutout feature, because this new user interface replaces the former user-defined cutout. Why have we done this? SMARTElectrode copies the selected burn faces to the electrode model and uses these copy geometry to compare the solid faces of the electrode against the burn faces copy. Doing this gives us the chance to find changes and help the designer to update after design changes. So let's have a look in Creo directly. So I will show the new functionality directly in the software. I think everybody knows, has basic knowledge about the software. So the first step, I create a new electrode model. And to start or get the cutout user interface, I have to select some surfaces to start with. So in this case, I'm going to use the seed and boundary surface. And start the cutout user interface. So you can see you have a wireframe highlight. The dashed line is the calculated outline of the selected surfaces, and the solid line is the outline plus the offset. In this user interface, you can now start to adjust all the values for position and size. And a new value is the C angle. So you can now even rotate your solid for the cutout. So this may be helpful if you have to create electrodes for angle geometry like ribs or something like that. And you can also adjust the position and the offset value to get a bigger cutout. So when you change back to 0, you can see the values for the position are reset again. So the necessary position is always recalculated based on your input. And when you're finally fine with the values, you can confirm that and the geometry and the cutout are created. So you can see these are the features created here in the bottom of the model tree. And if you want to come back to this user interface, you can select it and activate the redefine comment. Okay, some additional information about the copy geometry and the evaluation the software is doing for you. So I'm going to activate the workpiece and doing a small change. I'm using an offset expand feature. Activate the assembly. After that, again, you can already see it's regenerating and updating the electrode data. So there is no regeneration error. So for the designer, it seems okay. But when we now open the burn sheet and scroll downwards to the newly created electrode, you get a message that the copy geometry in the smart electrode number 10 has changed. So the designer gets a notification and now he can react and update the electrode solid. So let's activate this model again and start redefine. And we want to increase the size of this model. And to make sure our solid is big enough to have all the geometry inside the electrode. So now we have corrected this, and this is the process how a designer could start to integrate changes to the electrodes. There's maybe more functionality to come, but for the checks and evaluation, but that's it for now. Because mainly we would like to talk about the process streamlining. So let's go back to the presentation again. So the next topic is get more out of SMARTElectrode with the measuring points. We have two possible ways to create data for CMM. So one functionality is the datum points created by the designer, or color-coded surfaces. So the normal behavior, you start the user interface and then place measuring points at mouse pick position. The software is validating all of these points when you reopen the user interface. So all points outdated will be deleted from the model then. Or in the other direction, for a more automatic approach, you can use color codes. So there is a color configuration file in SMARTElectrode which is controlled by the option color format file. And this can be used to color features or named geom items in the electrode model. So using these color codes, you can save a step or IGES file, including the surface colors, and send it to a measuring device that is able to read the 3D data. What ways do we have to transfer the data? We have functionality to write formatted text files. This is also defined in the configuration. You can integrate these measuring points in your data output for EDM. You can embed the points in step or IGES, or you save a step or IGES file with surface colors. So I'm going to show that in Creo as well. So I already placed some points in the first electrode model. So I'm going to activate it and start the CMM Points user interface. And you can see there are the points placed at pick position. And there you can delete points or add new points if necessary. The format of the points in the user interface and the format of the saved file are coming from the configuration, as pointed out before. I'm going to save that file, and I'll show you the data which is created by SMARTElectrode. So you can see we have a sequence number and then the coordinates, and all the values are separated. And all of this can be customized to your needs. And let's go to the second solution we have for this measuring points. That would be points integrated in your data output for EDM. So this is this file. This is an example taken from an output for Zimmer and Crime. It's basically an XML file with information about the electrodes in this assembly. And here's a region with CMM points. And here it lists all the points placed for this electrode model. So when this data is transferred to Zimmer and Crime, they already have the measuring points information. So the third way for the transfer of data was the datum points integrated in a step file. So I'm going to import this again to Creo. So this is the normal electrode model for the electrode number 1, and these are the measuring points, and all of this data is exported for the electrode default coordinate system, which also can be customized in the options. Okay, so we have the last possible feature for the creation of measuring information. This is the color coding of the electrodes itself. So this is my default color code for electrodes. And what I can do now is I change the color format file in the options. And run the check functionality afterwards. And then you can see that all of the electrode colors have changed. So when I open one of the model, we have a specific color code for the electrodes free phase, specific color code for the orientation chamfer and for the frame. And color code for all the surfaces the software assumes as touching the workpiece. So the surfaces which would manufacture. So this is another electrode model with color code. So in the end, you could use this data set directly to save the electrodes, normally as step or IGES, if the configuration options in Creo are set for this. And then the measuring machines can import this and using this to validate your 3D data. Now I'm going to load my normal color configuration again. Okay. And let's go back to the slides. So we had this 4 ways to create the data for the following process. And maybe one of these solutions fits for you. So feel free to ask for more information or help. Let's go to the next topic, using manufacturing templates for Creo NC. So in collaboration with a partner, we created 3 new manufacturing templates. These will be released with 12.01. And we have one basic template. It's just an empty manufacturing assembly with some datums inside. One template for 3-axis milling with some basic milling sequences, and a 3-axis module works assembly, which can be used to create your own manufacturing templates if you're using Creo NC. Basically, the software loads the templates from the configuration, copies them to the working directory, and renames the files and updates the references inside the manufacturing assembly. So this means the reference part and the workpiece have to be replaced by the real models. So all of this is done by the software for you. And what are the advantages of this process? You can do the manufacturing stuff at any time you want. This means you can have one electrode designer and one NC programmer. And the NC programmer can start creating the manufacturing files in his time for that. And in the meantime, meanwhile, the electrode designer continues the project and design process. You can have also any number of templates. So for different use cases or different machines, or even for different production sites, or for different electrode materials, because the strategies for graphite or copper will be slightly different. So let's go back to Creo, and I'm going to show you the functionality we prepared for this manufacturing stuff. So there's a specific user interface for this, and just have to select an electrode by double click and select the template you would like to use for the manufacturing, and press OK, and you can see how the software is going to work in the background and reroutes the references. And now let's have a look into the models created. So you can see in the working directory you already have the new copied workpieces and the manufacturing assemblies. So the first one is basically empty. We have just only some prepared datums which are updated to fit the current setup. So this means we have a reject plane which has an offset from the NC0. We have a datum plane prepared for the middle window and another datum plane for the electrode depth. So the depth of the manufacturing sequences. The next template is pretty the same, but also includes now some milling sequences. So from face milling to roughing and the basic finishing, you can integrate everything in your templates and start the final programming from there. So let's play the path for this model. So this is what we got here. And the third one is using the new integrated high-speed milling sequences from ModuleWorks, which may include it in your Creo NC license. Just as an example, so you can start the definition of programming from these templates and create new templates or adjust the templates in the way they work. You can even integrate manufacturing sequences which need additional references. These manufacturing files will fail then if the references are missing, but you can update them by just redefining the references used for them. So this is the example for the milling. And well, maybe this is of interest for you if you're using Creo NC in the shop floor. Let's go back to the assembly at first and then back to the slides. The next or also final topic we have is the interfaces to EDM. So we have two user interfaces for this in SMARTElectrode. We have the basic data output. This is included in the normal license. This can be used for user-defined output, which means a backup, export as files as step or IGES for manufacturing, or you can create any kind of simple list where SMARTElectrode can replace a placeholder in the template directly with a parameter value from the electrode. And we have the more sophisticated post-processor. This needs an additional license option and is adapted to special EDM programming systems. So the functionality for the post-processors we have so far is evaluated by the manufacturers and the customers as well. And why should you use the interfaces? We have some advantages here. We have a huge time savings because you can omit the burn sheet, the drawing creation, and also in the programming department, because you don't have a user who has to interactively input all the values. And of course, you also avoid input errors during the programming, because some of the electrode projects can get really big, and if you have to input the values for around about 60 or 70 or even more electrodes, it's nearly can be hardly done without any errors. So what do we currently have for interfaces? We have several formats for Archie. This means the former Archie Vision and the pretty old Archie Innovation controls, and also the new unified Archie CMM format. And also Ingersoll, CMM Crime, Makino, which is using EPX format. So also Mitsubishi should be able to read the data. And we have some more manufacturers. We have the interface description, but currently no customers requesting the output for them. So this is Exaron, Sodic, and Owner. And we can also, of course, integrate custom formats on request. Okay, let's go to Creo again, and I'm going to show the difference between the normal output and the post-processor. So the selected type just creates a small text file where placeholders are replaced with parameters. So this is basically just a normal list. So you have the ID and the name and values describing the position and the undersize values. And this can be integrated by any user. And on the other side, we have the post-processing, where the software is going to write a more complicated export based on our implementation. So let's have a look. We have output for Archie in this case, and you can see it's there are a lot of files describing the electrode project. And as another example, I would like to show you the CMM Crime. It's going to take some time because this output also saves the drawings as PDF. So let's have a look on the data created. So we have this project has one big assembly drawing with a lot of sheets, a lot of drawing sheets. This is basically a complete list, the workpiece, and then electrode model and an electrode position sheet. And in the data output for CMM Crime, we have this big drawing splitted for the specific electrode models. So this means later on the guy at the machine can open the PDF and read the data directly from this PDF file. And we have the backup of the electrode models as step files. Remember the information about the CMM. So this can be a step file including datum points or including a specific surface color format for the measuring. And we have the XML file, which shows all the basic information like blank size, material, undersize, and all the position information, including end, start, and secure position. So, well, okay, these are some of the features in SMARTElectrode helping you to get your work done faster and more efficient. come back to the slides. Are there any questions so far?
Okay, hello, I'm Florian Todose. Well, we have first question. I'm used to the user-defined cutout. How do I adopt the new workflow?
Okay, as pointed out before, the user-defined cutout is not part of the software anymore. The one thing the users liked about the user-defined cutout was some kind of wireframe, which could be dragged in the position and size you would like to have. This is already on the list as an improvement for the current cutout. So this means when creating or redefining a cutout, you will get handles for dragging in one of the future releases, so maybe 12.01 or 12.02. And you won't lose any functionality because the user-defined feature cutout didn't copy any selected burn faces to the electrode. So therefore, the software uses information which can be used to validate the electrode. And integrating the handles here will help you to have the same workflow, but a better knowledge for the software. Okay, anything else?
Yeah, we have another question. How does the licensing for the post-processors work? Can I buy only one license?
Okay, the idea is, of course, you will need the basic SMARTElectrode license to buy the post-processor output option. What we can do if a customer has several SMARTElectrode licenses, we can create some kind of mixed license file. So maybe only one or two users get the output functionality, and the rest of the designers are just working with the normal SMARTElectrode extension without any additional output. Okay.
Okay, and one last question. How can I evaluate the post-processor functionality?
Okay, for evaluation, you can request a demo license from us. So in demo license, all of the functionality is accessible. And you can also ask for examples from us. So I can provide the data also used for the EDM manufacturers for validation. Okay, are there any more questions?
No more questions so far, so thank you very much.
Okay, thank you, Florian, for helping, and let's go back to the slides. Just as an additional information for you, we have some more webcasts in the pipeline for tomorrow, and then also for Thursday. Especially interesting is maybe also the Smart Assembly webcast. This is probably a tool you don't know yet, but it's a mighty scripting language to create your own automation for inside Creo. And if you are interested in attending these webcasts, just open the link shown and register for that. Okay. If you need or would like to have regular updates on our products, you can subscribe to our newsletter or to our YouTube channel, where we are trying to upload videos showing the usage of the software or any stuff we think that which may help. Okay, or if there are further questions, don't hesitate to contact us directly. And well, I would like to thank Florian for organizing this, and thank you for your attention, and have a nice day. Bye-bye.